Hi class, today we are diving into third grade math topics. Let's get started with our lesson. What am I showing you now? Yes, there are two textbooks, two leaves, and two coins. Can we find a unifying term to describe these things? Yes, we can call them objects. Look, what part of these objects have I colored red? I colored the surfaces of this object red. Let's observe together. Which surface is larger, which is smaller? The textbook's surface is the largest, and the cone's surface is smaller. Through observation, we can see that the surfaces of objects have different sizes. Today, we will learn about the size of an object's surface area. Now, please take out your worksheets and color the areas of these three plane figures completely. During the coloring process, everyone can easily color the surfaces of the rectangle and circle, but cannot do so for the third shape. Through this activity, you will find only closed shapes have area. No closed shapes do not have area. Therefore, we can get a more complete definition. Area is the size of an object's surface over the size of the closed shape. We have learned about another property of shapes before. Do you remember perimeter? Now, take our desk as an example to distinguish between perimeter and area together. Please use your finger to touch the perimeter of the desk. Then touch the entire area of the desk. While touching, say the definitions. Perimeter is the length around an object, and the area is the size of an object's surface or the size of a closed shape. Compare. Which shape has a larger area? How to compare the size of these two shapes? Since both have right angles and are rectangular, we can overlook them for comparison. The square has more remaining parts, so its area is larger. This method is called the counting and pasting method. Here are several vector lots of different shapes. Please think which one uses the most follow tellers and which used the least. Comparing the number of follow tellers used is actually compare the area of the vector loss. Through observation, we find that these shapes are all composed of squares of the same size. So, we can directly judge the area size by the number of squares contained in the vacant lot. By counting, we know the second shape has the smallest area, and the third shape has the largest area. This method of comparing area sizes is called the grid method. Now, please complete this question in groups. Then report the results and explain the method. Both shapes contain half grids. When counting, combine two half grids into one complete grid. Finally, we count that the first shape has an area of 16 grids and the second has 14 grids. So the first shape has a larger area. In this section, we mainly learned two things. Number one, the meaning of area. The size of an object's surface or a closed shape is its area. Number two, methods to compare the area sizes of two shapes. Observation method, counting and pasting method, grid method. Note: no matter which method is used for comparison, the standard must be unified in the same method. We've already learned the definition of area. Now, let's walk through exercise together to solidify and further our understanding of area. You will have 10 minutes to complete the questions, and then we will explain them once the 10 minutes are up. Time's up, everyone. We will begin going through the answer now. Number 1. Which of the following activities is related to area? Option A. Students measure their height. Height is related to length, so this is false. Option B. Stick lace around the wall. Newspaper. The length around an object is its perimeter, so this is false too. Option C. Paint the classroom walls. What we paint is the area of the walls, so this is true. Option D. Put a fence around the vegetable pot. This is still the length around an object, which is perimeter, So this is also false. Therefore, the answer is to question is option C. As shown in the figure, a rectangle is divided into two parts. What is true about these two parts? That we understand that we know the options. Option A, neither the perimeter nor the area is equal. Option B, both the perimeter and the area are equal. Option C, the areas are equal but the perimeters are not equal. D, the perimeters are equal but the area are not equal. By looking at the four options, we need to find the perimeter and the area of the two parts respectively. Due to the property of ranked angles, opposite sides are equal. So the two lengths are equal and the two widths are equal. Since the two sides of part 1 and part 2 correspond to the length and width of the rectangle respectively, so the two sides are equal in length. Part 1 and part 2 share the third side. According to the finishing to the perimeter, the total length around a closed figure. We can write the perimeter equations for part 1 and part 2. Perimeter of part 1 equal to length plus width plus the third side. Perimeter of part 2 equal to length plus width plus the third side. So the perimeters of part 1 and part 2 are equal. According to the definition of area, the size of the surface of a closed figure is its area. So the area of part 1 is larger than the part 2. The answer is D. Number 3. Compare 8 meters and 8 square meters. A. They are the same size. B. 8 square meters is larger. C. Cannot be compared. In future studies, we will learn that square meters are a unit of area. So 8 meters is a length, and 8 square meters is an area. Area and length are two different concepts, so they cannot be compared together. The answer is C. Next question. Use 12 squares with a side length of 1 centimeter to form a rectangle. How many ways are there to arrange them? According to the property of rectangles, opposite sides are equal. we can use these 12 squares to draw three different rectangles. The first one, rectangle with a length of 12 centimeters and a width of 1 centimeter. 2. A rectangle with a length of 6 centimeters and a width of 2 centimeters. 3. A rectangle with a length of 4 centimeters and a width of 3 centimeters. So the answer is C. The floor of Xiaoming's living room is covered with 126 floor tiles, and the floor of Xiaofang's living room is covered with 114 floor tiles. Then, what option need we choose? We will learn to compare the size of area. We always cover features with square grids of same size, and then compare the number of grids. However, in this question, we don't know if the floor tiles in Xiaofang's living room are same size as those in Xiaoming's living room. Therefore, we cannot compare them. So, the answer is D. As shown in the figures below, the area of each square grid in Figure 2 is 3 times that of each square grid in Figure 1. Compare the two figures, shape A and shape B. Which one has a larger area? The observation. Both figures contain incomplete square grids, but those incomplete grids can all be combined into complete ones. So, we can conclude shape A is made up of 19 grids. Shape B is made up of 7 grids. But the grids have different sizes. From the question, we know that one grid in Figure 2 is 3 times the size of one grid in Figure 1. Therefore, the 7 large grids in shape B are equivalent to 12 small grids. After unifying the grid size, we find that shape B has a larger area. Now we have finished learning the lesson. What is area? If I ask you what is area, what knowledge points will come to your mind? Now let's take a break. We will continue learning about area in 5 minutes.
Next, discuss in groups. What is the area of the math textbook? All of you thought of using grid method to determine the area of the math textbook. Here are the presentations of two groups. One group's measure results used 6 grids, and another used 20 grids. Why does the same textbook have different area measurements? Think about. Because the first group used larger grids, so the member is smaller. The second group used smaller grids, so the number is larger. If a classmate mentions the area of an object but doesn't show you the size of the grids used, can you preserve the actual size of object's area? How can we solve this problem? Very good. We need to unify the grids for measurements. That is, unify the units for measuring areas. As early as a long time ago, ancient people also realized the importance of unified area units. So they invited many area units for use. In daily life, the most commonly used ones are 1 square centimeter, 1 square decimeter, and 1 square meter. This is a standard square of 1 square centimeter, a square with a side length of 1 centimeter. Please observe it and with a ruler and share your findings. Through measuring and observation, this is a square with a side length of 1 centimeter. Therefore, a square with a side length of 1 centimeter has an area of 1 square centimeter. Now, draw 1 square centimeter on your exercise book to feel its size again. After that, find objects in daily life with an area of approximately 1 square centimeter. For example, the size of our fingernail, the surface of a pea, the size of a button are all about 1 square centimeter. So, can you measure the area of the desk with 1 square centimeter squares? Many of you encountered problems during the handmade measurement. You need many 1 square centimeter squares, and you must be very careful during measurement to avoid incorrect results. So we need to use a larger area unit to measure larger areas. This is a standard model of 1 square decimeter, a square with a side length of 1 decimeter. Please continue to observe with a ruler and clarify. Define 1 square decimeter. A square with a side length of 1 decimeter has an area of 1 square decimeter. Now use your hand to gesture the size of 1 square decimeter and find objects in daily life with an area of approximately 1 square decimeter. For example, the palm of your hand, one face on chart books. Next, use 1 square decimeter squares to measure the area of the desk and feel if it is appropriate to use square decimeters as a unit for measuring the desk. The area of a desk is about 30 square decimeters. So what if we measure the area of the classroom floor? Is it appropriate to use square decimeters? Based on our previous experience, you will quickly realize that we need to use a larger area unit. This is a standard model of 1 square meter, a square with a side length of 1 meter, which can be formed by 4-meter sticks. Please observe it and clearly define 1 square meter. 1 square with a side length of 1 meter has an area of 1 square meter. Now use your body to gesture the size of 1 square meter. Think about and talk about in our daily life where square meters are used. Okay, we usually use square meters as the unit when measuring room area or playground area. Now we do some practice. Fill in the blank with the most suitable area unit. I give you 1 minute. First, the area of a living room floor is about, yes, 50 square meters. Second, the area of a notebook is about 2 square decimeters. Third, the area of a postage stamp is about 6 square centimeters. Next question, true or false? Area units are larger than length units. Yes, it's false. The reasoning is area and length are two distinct concepts. Area units and length units are different kinds of measuring units and therefore cannot be directly compared. Okay, multiple choice. The area of Pongpong's living room is approximately 30. Yeah, it's a big size, so we choose C, square meters. Okay, in this section, what key concepts did we cover today? First, the common area units are the square centimeter, square decimeter, and square meter. Second, we use square centimeter for measuring smaller areas. Use square decimeter for measuring medium-sized areas and square meters for measuring larger areas. Third, comparing these three area units. 1 square centimeter is smaller than 1 square decimeter, smaller than 1 square meters. We learned about Long's units before. Let's invite a student to help us review. The Long's units we learned from smallest to largest are millimeter, centimeter, decimeter, and meter. So the conversation rate between each pair of adjacent Long's units is 10. At this point, do you have any questions in mind? Long's units are included in the names of area units. Is there a connection between Long's units and area units? Long's units have conversation rates. So, do area units have conversation rates? If so, what are they? Let's solve this question together. If you use small 1 square centimeter squares to completely cover a large 1 square decimeter square, how many small squares do you need? Now, group cooperation and exploration. I will give you 5 minutes. Okay, here is the exploration process of one group. When you tried to cover the 1 decimeter square with 1 centimeter small squares, they found that the small squares were too scattered and easy to shift during operation. So they draw 1 square centimeter small squares in the large square with a ruler. Through graphical analysis, the side lengths of 1 decimeter equal 10 centimeter. So we can place 10 small squares in one row and 10 rows in total. So the total number is 10 multiplied 10 equal 100. In conclusion, 1 square decimeter equal 100 square centimeter. So how many 1 square decimeter squares are needed to cover a 1 square meter square? Through transfer reasoning, the side lengths of 1 meter equal 1 meter equal 10 decimeter. So we can place 10 1 square decimeter squares in one row and 10 rows in total. So the total number is 10 multiplied 10 equal 100. Yeah, we can see this picture. Now let's do some class practice. Fill in the blanks. 3 square centimeter equal 300 square decimeters. 400 square centimeters equal 4 square decimeters. 900 square decimeters equal 9 square meters. 700 square decimeters equal 7 square meters. These 4 questions are all about area units. Now another 2. 2 meters equal 200 decimeters. 140 centimeters equal 14 decimeters. These 2 questions is about longs units. True or false? The conversation rate between any 2 area units is 100. The conversation factor is not 100 for any 2 arbitrary area units. Among the square meter, square decimeter, and the square centimeter, the conversation factor is 100 only between 2 adjacent units. So this question is false. A square table has a tabletop with a side length of 80 centimeters. A tablecloth the same size as a tabletop is needed. What is the area of the tablecloth in square centimeters? What is the area in square decimeters? First, we should calculate the area. 80 multiply 80 equal 6,400 square centimeter. And 6,400 square centimeters equal 64 square decimeter. So the answer is 60,400 square centimeter, 64 square decimeter. We should use the formula area of a square equal side lengths times side lengths. Now, this is an extension question. A square meters equal how many square centimeters? Okay. Now, in this class, what key knowledge did you learn this lesson? First, what is area? Second, what are the common area units? Third, what is the conversation between adjacent units? I think all of you can solve the problems. Now, I will give you some homework. Go home and measure the area of your desk and the book cover, noting the unit used. Second, complete the exercise on the worksheet. Okay, class over.